Welcome to Lucid Mind Chemistry channel. In this video, I have put together some questions related to the topic SN1 mechanism in tertiary halogenoalkanes. For links to other topics and question timestamps, please visit video description. Question 25. Sodium methoxide NaCH3O reacts with 2-chloro-2-methylpropane in a nucleophilic substitution reaction. The nucleophile is CH3O negative ion. Which row is correct? First one, we have to find the intermediate or transition state. Then we have to find the product. 2-chloro-2-methylpropane is like this. We have propane as it is 3-carbon long chain. On second carbon we have chloro, we also have methyl group. Now this is an example of tertiary alkyl halide because this carbon is directly attached with 3 other carbon atoms. Now tertiary alkyl halide always undergoes nucleophilic substitution, which is SN1. And what happens is that first this bond is broken by heterolytic fission and we have these two products CH3, CCH3. This one becomes positive and Cl is removed. Now in second step, as the nucleophile is CH3O negative, so this will attack this carbocation and form this product. We have CH3O carbon, then 3 methyl groups are also attached. So first is the intermediate. This is the intermediate or transition state. C and D are not true. These are for primary halogenoalkanes. Now this product formed can also be written like this. We have 3 methyl groups attached with this carbon, so we can write 3CH3. Then we have this carbon atom, this oxygen atom, and this CH3 is also present. This is similar to this product, therefore answer is A. Question 28. 2-methyl-butene reacts with HBr gas to form 2 isomeric products. During the reaction, 2 positively charged intermediates can be made. Which diagram shows the more stable of the 2 positively charged intermediates? Let's first find out which type of intermediate is formed during the reaction. So we have 2-methyl-butene. On second carbon we have double bond. It reacts with HBr as Br is partial negative and hydrogen is partial positive. So therefore H plus will be attached to the carbon atom with the double bond. With one of the carbon atom H plus is attached and on the second carbon atom cation will be formed. Now for the product there are 2 possibilities. One is that hydrogen combines with the first carbon atom and second carbon becomes the positive ion. Second possibility is that the hydrogen attaches itself to the second carbon atom and cation is formed on the first one. Now in the second step, bromide ion will react with the partial positive carbon atom and will form the product. Now looking at the given options, we can see that C and D are wrong because they have attached bromine first and only A and B are left behind. So among A and B we can see that there are 3 alkyl group attached with this carbocation and there are 2 alkyl groups attached to this carbocation. A is tertiary carbocation and B is secondary carbocation. Now tertiary carbocation is always more stable than secondary carbocation because of the presence of alkyl groups. And due to the alkyl groups, there is electron donating effect and it stabilizes the intermediate carbocation. So therefore A is more stable among A and B. Question 25. 1-chloro-1-methyl cyclohexane is hydrolyzed by heating with sodium hydroxide. We have the product. The reaction pathway is shown. One carbon atom in 1-chloro-1-methyl cyclohexane is bonded to 3 other carbon atoms. What is the charge on this carbon atom at point Z? Let's find the carbon atom that is bonded to 3 other carbon atoms. We have this carbon, and it is bonded with this carbon, and this carbon. So this is tertiary halogenoalkane. Now we can see that in this reaction OH is replacing Cl. So therefore this is nucleophilic substitution reaction. The nucleophilic substitution of tertiary halogenoalkane takes place in 2 steps. In the first step, what happens that carbocation is formed. In the second step, the carbocation will react with Cl negative to form substituted product. Now the first step is slow step, so it will need high activation energy. So this hump is for first step. In second step, carbocation has been formed, which reacts with chlorine to form the product. So the energy for second step is low, so the hump is smaller. As the charge on carbocation is +1, so therefore answer is D. Question number 38. Halogenoalkanes can be hydrolyzed using aqueous sodium hydroxide. Which compounds tend to be hydrolyzed by an SN1 mechanism? Now, in order to follow the SN1 mechanism, the halogenoalkane must be a tertiary halogenoalkane. Let's draw the structures of these 3 given compounds, and then we can find out which one is primary, secondary or tertiary halogenoalkane. So first one is carbon, then second carbon, then third carbon, then chlorine is attached with the third carbon atom, CH3 is also attached with the third carbon atom. Then we have fourth carbon, CH2. Then the last carbon, CH3. So it will be Cl and CH3. Now we can find out whether the halogenoalkane is tertiary by looking at the halogen. This Cl halogen is attached to this carbon atom, and this carbon is directly attached with 3 other carbon atoms. So therefore this is tertiary structure. So it will be hydrolyzed by SN1 mechanism. Now let's draw the second one. We have 1 carbon, 2 carbons, 3 carbons, 1, 2, 3, and with the third carbon bromine is attached and CH3 is also attached. Then we have CH2 and CH3. Again we can see that the halogen is attached to this carbon atom, and this carbon is directly attached with 3 other carbon atoms. So therefore this is also tertiary halogenoalkane, and it will undergo through SN1 mechanism. Let's draw a third one. We have 1, 2, 3 carbon atoms, and this CH3 is attached with this carbon atom. Then fourth and fifth carbon atom, fourth and fifth, and then this bromine is attached to this last carbon. Now we can see that the halogen is attached to this carbon atom, which is further attached to just one carbon atom directly. So therefore this is primary halogenoalkane. It will undergo through SN2 mechanism. So therefore this is incorrect. So option 1 and 2 are correct. So therefore answer is B. Question 25. Which statement about the mechanism of an SN1 reaction of a halogenoalkane is correct? Now SN1 reaction is carried out by tertiary halogenoalkanes. In the mechanism we can see that tertiary halogenoalkane is first converted into carbocation and halogen is removed. Then in second step, electrophile attaches itself with the carbocation that is formed to form product. Let's look into the option A. A nucleophile is substituted by an electrophile. As we can see that both X negative and E negative are nucleophiles because they have negative charge. So therefore A is incorrect. B. One intermediate is formed from two reacting molecules. As we have one reacting molecules that forms two intermediates, so therefore B is also incorrect. C. The intermediate is stabilized by adjacent alkyl groups. Now we can see that this carbocation is stabilized by these three alkyl groups because alkyl groups are actually electron donating in nature, and due to positive inductive effect it stabilizes the carbocation that is positive. So C is correct. D. The intermediate is uncharged. As we can see that there is positive charge present on the intermediate, so therefore D is also incorrect. Correct answer is therefore C. Question 25. When warm water is added to halogenoalkane X, an SN1 reaction occurs. Silver nitrate aqueous is then added, a yellow precipitate is formed. What could be X? SN1 mechanism is shown by tertiary halogenoalkanes. Let's see which option shows tertiary halogenoalkane. First one is 1-chlorobutane. So we have 4 carbon atoms in the long chain and chlorine is present on first carbon. As the carbon attached with chlorine is further attached to one carbon atom, so this is primary halogenoalkane. So 1 is incorrect. In B we have 1-iodobutane. So again we have 4 carbon atoms in the long chain and on first carbon atom iodine is present. So as this carbon that is attached with iodine is attached only with one carbon atom directly, so this is also primary halogenoalkane. So both A and B are incorrect. In part C we have 2-chloro, 2-methyl propane. So in long chain we have 3 carbon atoms as it is propane. On second carbon we have chloro and on second carbon we also have methyl functional group. Now as we can see that the carbon atom attached with chlorine is attached to 3 carbon atoms directly, so this is tertiary halogenoalkane. So this will follow SN1 mechanism. And the precipitate that is formed with silver nitrate is silver chloride. Now AgCl is silver in color, while in question yellow precipitate is formed, so therefore C is incorrect. In part D we have 2-iodo, 2-methyl propane. Again we have 3 carbon atoms in the long chain. On second carbon we have iodo and methyl. As the carbon atom attached with iodine is further attached with 3 carbon atoms directly, so this is tertiary halogenoalkane and it will follow SN1 mechanism. Second thing is the formation of precipitate. As we have iodine, so it will form AgI with silver nitrate. and AgI is yellow in color. So as in the question, yellow precipitate was given, so therefore D could be correct option. The answer is therefore D. Question 23. A tertiary bromoalkane indicated here by CBr reacts with aqueous sodium hydroxide. The mechanism has the reaction pathway shown. Now we can see there are two components. One is X having high energy. Second is Y having low energy. On Y-axis we have energy given, and on X-axis we have progress of the reaction. These are the reactants and this is the product that is formed. Which point in the diagram is correctly identified? In the question, tertiary bromoalkane is given, which is CBr. So what happens with the tertiary bromoalkane substitution? There are three alkyl groups attached with these carbon atoms directly. Bromine is electronegative, so it has partial negative charge, while the charge on carbon is partial positive. Now what happens in substitution? That in the first step this bond will be broken and tertiary carbocation is formed. Now this tertiary carbocation is stable because there are three alkyl groups directly attached, and because of the positive inductive effect it stabilizes the carbocation. Now this carbocation is a stable product. Now the stable product must have low energy. In the diagram we have X is at high energy and Y is at low energy. So therefore this product should be Y. In option A, X is given as C positive carbocation intermediate. This is incorrect because X is at high energy. In B, X is given as this intermediate. Now this is incorrect because this transition state is formed from primary halogenoalkanes. While the one given in the question is tertiary halogenoalkane. In C, it is given that Y is carbocation. Now as Y is at low energy, so this should be correct option. In D, Y is given as this transition state. Again, this is incorrect because this is for primary halogenoalkane. Correct answer is therefore C. Question 38. The halogenoalkanes listed below all react with sodium hydroxide, which reactions proceed mainly by an SN1 mechanism. Now you should know that SN1 mechanism is followed by tertiary halogenoalkanes. Let's find out which one is tertiary. First one is 1-iodopropane. So we have 3 carbon atoms in the long chain as it is propane, and iodine is present on first carbon atom. As we can see that the carbon atom attached with iodine is directly attached with just one carbon atom, so therefore it is primary halogenoalkane. So 1 is incorrect. 2 is 2-iodo-2-methylpropane. Again we have 3 carbon atoms in the long chain as it is propane. On second carbon we have iodo, and on second carbon we also have methyl group, so it is iodo and methyl. As iodine is attached with the carbon atom which is directly attached to 3 other carbon atoms, so therefore this is tertiary halogenoalkane. So this will go through SN1 mechanism. Third one is 2-bromo-2-methylbutane. As it is butane, so we have 4 carbon atoms in the long chain. On second carbon atom we have bromo, and on second we also have methyl group. Again you can see that the carbon atom attached with bromine is directly attached with 3 other carbon atoms, so therefore this is also tertiary halogenoalkane. So it will go through SN1 mechanism. As option 2 and 3 are correct, the answer is therefore C. Question 38. Halogenoalkanes can undergo reaction with hydroxide ions. Halogen is replaced by OH to form alcohol and halide ion. The reactions of some halogenoalkanes proceeds by SN1 mechanism. Which statement about SN1 mechanism are correct? Number 1. A carbocation is formed which is stabilized by the inductive effect of the alkyl groups present. Now this is true for tertiary halogenoalkanes. In tertiary halogenoalkanes, the carbon atom having halogen is attached to 3 carbon atoms directly. Now what happens? First, carbocation is formed. And in heterolytic fission, bromine atom is lost. Now this carbocation is stabilized by these methyl groups, as methyl groups have positive inductive effect by which they donate their electrons to this carbocation to make it stable. So statement 1 is correct. Part 2. Only tertiary halogenoalkanes are hydrolyzed in this way. Now tertiary halogenoalkanes always take SN1 mechanism, while secondary halogenoalkanes can go through SN1 as well as SN2. Option 3. The intermediate formed includes a carbon atom with 5 bonds attached to it. In tertiary halogenoalkanes this is not true, but in primary halogenoalkanes this is true, as SN1 is of tertiary halogenoalkane, so this is wrong. Option 1 is correct, the answer is D. Question 22. Sodium methoxide Na plus CH3O negative reacts with 2-chloro-2-methylpropane in a nucleophilic substitution reaction. The nucleophile is this one. Which row is correct? First you have to find out the intermediate or transition state, and then you have to find out the product. Let's first draw the structure of 2-chloro-2-methylpropane. So in long chain we have 3 carbon atoms as it is propane. On second carbon we have chloro, and we also have methyl group attached. As we can see that the electronegative chlorine is attached with this carbon atom, which is directly attached with 3 alkyl groups, so therefore this is tertiary halogenoalkane. And in tertiary halogenoalkane, nucleophilic substitution reaction takes place in such a way that this compound is first converted into this product, which is carbocation. And then in second step, CH3O negative will attack this carbon and form product. As all these methyl groups are similar, so we can write CH3 twice. Then we have carbon and oxygen. Then we have CH3. So now the intermediate formed is this one, which shows this. The product formed is this one, which is equivalent to this product. The answer is therefore A. Thanks for watching. If this was useful, please do like, subscribe and share.